All right, you college algebra kids. You guys are freaking out about little algebraic domain and range, so I believe these are some of the homework problems I received some questions on. I'm not doing those. We're going to do the ones right down here. Oh, focus. Let's focus. And then you should be able to apply the examples from this knowledge up here. And please also know this is our exact lesson for tomorrow. First, there are two important things to note when it comes to the domain and range. Or the domain. We're just going to talk about domain right now. One, you cannot have our favorite. We know that it explodes the world. We cannot have zeros in the denominator. And as we know, our favorite, imaginary numbers, that's going to be a problem when we talk about the domain. So the other big thing is we can have no input that leaves a negative radical. Notes. So let's look at the problem number one. So remember, domain, find the domain, is just a fancy way to say what are all of the valid inputs or all of the valid x values of this function. The easiest way that we're going to see the valid inputs in the domain is going to be through a graph, but sometimes we like to make you do it algebraically. So right here, let's do our two tests. Is there a fraction? So is it possible for a 0 to be in the denominator? I don't see a fraction. Do I see a square root? Is it possible to have a negative radical? I don't see a square root. So in theory, it looks like there's no issue here. There's going to be no restrictions on our domain, as we say. If we plug in any x value, we're going to get a valid real number. And if we look at the graph, we see it's a classic quadratic. And if we continue to zoom out, we see there seems to be no issue. On both with the positive x values and negative x values, it seems to be going on forever. There's no issue, there's no interruption. So in this case, every single x value that you can possibly think of is part of the domain. And so the way we're going to write that is in parentheses. We're going to say you can go all the way down to numbers for, negative infinity. Pretend that's an infinity symbol, comma, positive infinity. And this right here is interval notation, and it means that any single number you want, you can plug it in for x, and you will get a valid number for your y value output. Here's a similar one where we start seeing a rational function. As we know, rational function meaning that there's variables in the denominator. Now we talked about this last year, and we talked about vertical asymptotes, VA. Remember that? Vertical asymptotes. And whenever we have a rational function, the vertical asymptotes are going to give us the restrictions that we need to keep a track of on the domain. And remember, vertical asymptote is any x value that you would plug in here, and it would give a value of 0 as a factor in the denominator. So right here, in order to show your work, you would take each factor, we see 1, 2 factors here, and you would set both of them equal to 0. And then solve for what x value is going to make that equation equal to 0. And in this one, we see it's going to be x equals -2. Over here, x equals -5. And we know that if we put in here, -2 plus 2 is 0, boom, the world explodes. Same thing here, -5 plus 5 is 0, boom, the world explodes. So we know that these are not part of our graph. They're those vertical asymptotes, which is not part of the function. So that means it's also not part of the domain. X is not allowed to equal -2, and it's not allowed to equal -5, since those are factors in the denominator. And if we look here, we see that the graph confirms the algebra that it just told us. If we go where the input, where x is -2, we see there's no output. The graph is nowhere to be seen when x is at -2. We see that's also the case over here at -5. At the input of -5, there's no graph, there's no output. So right here we see that there's no domain, the domain does not exist at -2 or -5. So now we have to figure out what that looks like in interval notation. So we know x is not allowed to be -2, x is not allowed to be -5, because those values would produce a 0 factor in the denominator. So we need to do some interval notation. First of all, -5 is a smaller number than -2, so we're going to start with that when we're thinking about all the smallest numbers that are allowed. Now remember, these are the only two numbers that aren't allowed. So any number lower than -5, we can plug in and this function is going to be okay, and the graph confirms that. So the way we write any number below something is we put negative infinity, comma, that number. And that means and we put a parentheses here, and that means any single number that's below -5 is allowed. And we're gonna put a parentheses here, because a parentheses in our math means -5 isn't allowed, which is what we see in our math up here. And then we're going to say union. We're going to say, yep, -5 is still not allowed. That's why we use the parentheses. But then any number in between -5 traveling to -2 is allowed, but -2 is also not in the domain. So we always use parentheses when that number is not allowed in the domain. Union, -2 is still not allowed, but any single number that's bigger than -2 is allowed. And the way that we communicate that any number bigger than a number is allowed is we put comma, and we put a positive infinity in close parentheses. Now when we have radicals, we just said the restriction is any number that will give you a negative underneath is not allowed to be this. So we can set up in a little equation to let us know what all those numbers are. We know that whatever number here that we plug in, our resulting answer must be bigger or equal to 0. And now we can solve for x, and we can see that our x value must be greater than or equal to +4. If we plug in anything lower than 4, it's going to give us a negative number. So like if we pick 3 minus 4 is -1, we can't do that. If we pick 2 minus 4 is -2, we can't do that. But 4 or bigger, we're going to end up with 0 or a positive number, so we're going to be good to go. You're just not allowed to get negatives. So now we need to reflect that you can have any number that's 4 or larger. Now, in order to communicate a number, any single number that's larger, because remember that's x is greater than or equal to 4, any single number that is larger than 4 is allowed. And we show that by putting the positive infinity sign right after it. And we're gonna put the 4 right next to it. So that means 4 and any number larger than it. And we have to think, is 4 allowed to be one of the inputs? That's greater than or equal to, so it is. So we use a bracket to show that 4 is allowed in the domain.